Find the equation of the tangent line to the function f of x equals 5x cubed minus 2x squared plus 1 at the point 1/2, 9/8. Okay, so we want to find the tangent line. That means first we should find the slope of the tangent line. And to do that, we need to take the derivative. So the derivative of this function, which would be f prime of x, would be, well, the derivative of 5x cubed, to bring down the 3, that'll be a 15. And then subtract 1 from the exponent, makes that a 2. And then the negative 2x squared, 2 and 2 is 4. And then that'll just be x, 2 minus 1 is x. And the derivative of a constant is 0, so that goes away. So that's the derivative. Now, if I want the slope of the tangent line at this point 1/2, 9/8, I need to plug in the x-coordinate, 1/2. So f prime of a half, that's going to be 15 times 1/2 squared minus 4 times 1/2. And that's going to be equal to 15 times 1/4. 1/2 squared is 1/4. Minus 4 times a half. That's like 4 halves, which is 2. And let's turn this into one fraction here. So this is 15/4 minus, and then if I want to write this as a fourths, this would be an 8. 8 over 4 is the same thing as 2. And 15 minus 8 is 7, so this will be 7/4. Okay, so now I know the slope. The slope is 7/4, and I have a point on the graph, 1/2, 9/8, and so I can actually get the equation for this. So the equation of a line is y equals mx plus b, and I can plug in the point for x and for y. So 9/8 is y equals, and the slope m is 7/4, and x is 1/2 plus b. And I can solve this for b. So if I do this, that's going to be 9/8 minus, and then this is 7/8. 7/4 times 1/2 is 7/8. And so 9 minus 7, that is 2/8 or 1/4. So the equation of my tangent line is going to be y equals, let's see, the slope, 7/4, x plus the y-intercept, 1/4. So let's take a look at the graph. This is the graph of the function without the tangent line. And you can see that the point 1/2, 9/8, that's this point right there. And so when we add in a tangent line, we would expect a tangent line to be sloping positive slope. Well, we have a slope of 7/4, so that makes sense. So if I add in the tangent line, there it is, looks about right. So for this type of problem, you need to take a derivative, plug in the x-coordinate, that'll give you the slope, and then use the point and the slope to get the equation of the line.